let us discuss some of the properties of matrix addition and multiplication. What are the properties of matrix addition? The first one, commutative law. So I have matrix A plus B is definitely equal to matrix B plus A. And 2, associative law. So we have matrix A plus B plus C is definitely equal to A plus B plus C. Right? So very simple. Let me take two matrices 1, 2, 4, 5, B 2, 6, 7, 8, and C 1, 1, 2, 2. So very easy, whether I do A plus B or B plus A, the values are the same. So what is A plus B? 1 plus 2 is 3, 2 plus 6 is 8, 7 plus 4 is 11, and 8 plus 5 is 13. And what is B plus A? 2 plus 1 is 3, 6 plus 2 is 8, 7 plus 4 is 11, 8 plus 5 is 13. Right? So similarly, the associative law can be easily proved. So you can take three matrices, add these two plus C will give me the same answer as B plus C plus A. Right? So now let us go through some of the properties of matrix multiplication which are more important. Right? So let's see the properties of matrix multiplication. The first property states that multiplication is not commutative. That is, A into B is not equal to B into A. So this is very important. So let's take an example. So I have matrix A, which is 1, 2, minus 2, 3. B is 2, 1, 2, 3. Okay? So what is A into B? So I have 1 into first row into first column. So we have 1 into 2 plus 2 into 2 is 4. Next, first row into second column is 1 into 1 plus 2 into 3 is 6. Next, second row into first column, minus 2 into 2 is minus 4, 3 into 2 is 6. And then second row into second column is minus 2 plus 9. Right? So A into B gives me 6, then 7. And here I have minus 4 plus 6 is 2, and then minus 2 plus 9 is 7. So this is A into B. So now let's do B into A. So for B into A, I multiply the first row with the first column. Right? So I consider the elements of B first. So first row into first column. For reference, let me write matrix A here. 1 minus 2, 2, 3. So first row into first column, 2 into 1 is 2. 1 into minus 2 is minus 2. Next, first row into second column is 2 into 2 is 4 plus 3 into 1 is 3. Second row into first column, 2 into 1 is 2 minus 6. And then 2 into 2 is 4 plus 3 into 3 is 9. So what is B into A? 2 minus 2 is 0. 4 plus 3 is 7. 2 minus 6 is minus 4. 4 plus 9 is 13. Right? So definitely we observe that A into B is not equal to B into A. Right? So matrix multiplication is not commutative. So this is a very important property. Now what is the second property? The second property states that matrix multiplication is associative. It is associative. So what does this mean? This means A into B into C is definitely equal to A into B into C. So let's again take an example. So I have matrix C. So let me consider matrix C as minus 3, 1, 2 and 0. Okay. So I already have AB. So now let me do A into B into C. Right? So I need to multiply these two matrices. First row into first column. So 6 into minus 3 is minus 18. First row into first column. 7 into 2 is 14. Next, first row into second column. 6 into 1 plus 7 into 0. Next, second row into first column. 2 into minus 3 is minus 6, and then 7 into 2 is plus 14. Next, second row into second column, 2 into 1 plus 0. So we end up getting minus 4, 6, and then you have 8 and 2. Right? So this is A into B into C. So now let's see B into C. So what is B into C? I have matrix B, let me multiply it with C. First row into first column, so I have minus 6 plus 2. I'm doing a bit fast because the multiplication process is quite trivial. 2 into 0, 2 plus 0, 2 into 1 plus 1 into 0. Next we have 2 into minus 3 is minus 6 plus 6, and then you have 2 plus 0. Right? So B into C gives me minus 4, 2, 0, 2. Okay? So now let me multiply A into B into C. That means I need to multiply these two matrices. So 1 into minus 4 plus 2 into 0. Next, first row into second column, 1 into 2 plus 2 into 2. Next I have minus 2 into minus 4. Second row into first column, that is 8 plus 0. And then I have minus 2 into 2, which is minus 4 plus 6. So we get minus 4, 6, 8 and 2. So these two matrices are equal. So A into B into C is equal to A into B into C. So matrix multiplication is definitely associative. So the next property states that, so the third property states that it is distributive. So what does this mean? So I have matrix A into B plus C equals AB plus AC. Right? So let us prove this by using these three matrices. So the first one is B plus C. Matrix B plus C is B into C. So adding the individual elements. 2 into minus 3 is minus 1. 1 plus 1 is 2. 2 plus 2 is 4. 3 plus 0 is 3. Right? So now let me multiply A into B plus C. So first row into first column, so I have, right, first row into first column minus 1 plus 8. First row into second column, so it is 2 plus 6. Next, second row into first column, minus 2 into minus 1 is 2. So 2 plus 12. And then I have minus 4 plus 9. So we end up getting 7, 8, 14 and 5. Right? So this is A into B plus C. Now we already have AB, so let me do AC. Matrix A into C. So first row into first column is minus 3 plus 4. Next, first row into second column is 1 plus 0. Next, A into C, minus 2 into minus 3 is 6. 6 plus 6, and then minus 2 into 1 is minus 2 plus 0. So we get 1, 1, 12 minus 2. Right? So now I need to add these two, AB plus AC. So AB plus AC. So I am adding these two values. So 6 plus 1 is 7, 7 plus 1 is 8, 12 plus 2 is 14, and here I have 7 minus 2 is 5. So these two matrices are equal. So therefore, A into B plus C is equal to AB plus AC. So we have proved the distributive law with an example. The next one, let us consider multiplication of a given matrix with the identity or unit matrix. So what does that state? So if I have a matrix A, and if I multiply it with the identity matrix, it is equal to A. Or if I multiply identity matrix with A is also equal to A. So let me consider A and let me consider identity matrix. What is identity or unit matrix? It is a diagonal matrix where the elements along the principal diagonal are 1 and the others are 0. Right? So now what is A into I? First row into first column, 1 into 1 plus 2 into 0 is 0. Next, 1 into 0 plus 2 into 1. Next, minus 2 into 1 plus 3 into 0. Next, minus 2 into 0 plus 3 into 1. So I end up getting 1, 2, minus 2 and 3, which is nothing but A. Right? So now let me multiply I into A. Okay? So I into A. So let me write matrix A here. So what is I into A? 1 into 1 plus 0. 1 into 2 plus 0. 0 into 1 minus 2. 0 into 2 plus 3. So we end up getting A itself. Right? So therefore, I into A is equal to A into I is equal to I. The very important property of matrix multiplication. So let us also observe another important result. So another important result is a matrix A into its inverse is equal to inverse of matrix into A is equal to the identity matrix I if determinant A is not equal to 0. Right? So if I multiply a matrix with its inverse, it is definitely equal to the identity matrix. So we should prove this with an example in the next video lecture when we discuss how to find the inverse from matrix A. Right? So that we will find the inverse of a 2 cross 2 matrix and then a 3 cross 3 matrix and then take an example and see how this is true. Now we will also verify A into B transpose equals B transpose into A transpose. So let's take an example. So again I have matrix A, we'll take the same values, 1, 2, minus 2, 3, and then B equals 2, 1, 2, 3. And what was AB? We had just calculated the values of AB. The value of AB is 6, 7, 2, 7. Right? 2 plus 4 is 6, 1 plus 6 is 7, minus 4 plus 6 is 2, and then minus 1 plus minus 7. Right? So what is AB transpose? AB transpose is replacing, or you write the column as a row. So the first column is written as the row 6, 2, and the second column is written as the second row 7, 7. So this is AB transpose. So now let us do B transpose into A transpose. So B transpose is writing the first column as a row 2, 2, and the second column as the second row 1, 3. A transpose is the first column as the first row, the second column as the second row. Let us multiply these two matrices, B transpose into A transpose. So what does this give me? 2 into 2 plus 2 into 1 plus 2 into 2. So 2 plus 4. 2 into minus 2 is minus 4 plus 6. Next, the second row in first column, 1 into 1 plus 3 into 2. And then I have 1 into minus 2, which is minus 2 plus 3 into 3 is 9. So we get 6 plus 2, 7 plus 7. So what we observe, these two matrices are equal, right? So therefore, A into B transpose is equal to B transpose into A transpose, right? So in this lecture session, we have seen some of the properties of matrix addition and matrix multiplication, and we have taken an example and we have proved these properties. Okay? In the coming session, we will take a matrix and see how to find the inverse of a matrix, a 2 cross 2 matrix and a 3 cross 3 matrix.